So hi everyone, today we are again here with a new problem of TSA. Today we are going to solve the problem of binary tree, that is problem number 404, sum of left leaves. So what is the problem? Let's read it. Given the root of a binary tree, return the sum of all left leaves. A leaf of is a node with no children. A left leaf is a leaf that is left child of another node. Okay, so in this problem, we have to find the sum of left leaves. Means the leaf which is on the left side and also the last child. So let's take an example and also understand the approach that how we will going to solve this problem. Suppose this is our binary tree and we have to find the sum of left leaves. So the answer would be like this. So we can see this. These are the leaves which is on the left side. So the answer would be 4 plus 6. So 4 is on the left side and it is also the leaf node. And here 6 is also on the left side and it is also on the left side and also the leaf node. And again we can see over here that the final is that 10. 10 is on the left side and also the leaf node. So the plus 10, as we can see, there is no any other leaf which is on the left side. So the answer will be 20. I hope that the question is clear to you all. Now we will going to discuss about the approach, that how we will going to solve this problem. So as we can see that we have to find the sum only of the left leaf nodes. So first of all, let us understand that what is leaf node, how we can say that this is the leaf node. So we can see that there is no any other child. No, nothing is on the left side, nothing is on the right side. So we can see the property of leaf node, that is that it is the last node, means it has nothing on the left side and nothing on the right side. Means if we are on this root, then we can say that root dot left equals to null, or we can say none in Python, and root dot right also null. So as we can say that we have just find the sum of left side. So what we can do, that we can pass one Boolean value also along with this while traversing. So suppose we are traversing from here and initially we pass false. So as we go on the left side, what we pass? We pass true. As we are going left, we just pass with it true. And again we go on the left side. So we reach up to here 4. And at every position we check that if root dot left means the left side of any root and the right side of the any root is null. So if both the values are null and also the Boolean value is true, so we take that value in our sum. So let's take an example. Suppose we are to start traversing from over here and at this point Boolean value is false. So I will write F for false. Okay, so we go on the left side. So here Boolean value is true, T for true. But we can say that this root have its left child and also the right child. So we will not going to add it. Now we again go on left and we can see, check again same condition over here. The left side is null and also the right side also null. And we are on the left side, so the Boolean value over here is true. So we will take this 4 as our part. So as we can see, let's take another color. So we can see over here, we take this 4 in our solution. Now since we are doing recursion, we will going to backtrack it. So we will again go on 2, and this time we go on right side. So as we go on right side, what we do, we put this true value as false. So means here we can say that the boolean value is false. And now since the boolean value is false, we will not going to take this 5 as our part of answer. Now we will go on left side. So since we go on left side, the boolean value will get true. And here we can see that the left and right both are null. So we will take this 6 as a part of our answer. So here we can see that we have taken this 6. Now again, since it's a recursion, it will go back to its this one, because we have traversed whole this left tree. Now from here we will go to right. Since it is right, the boolean value will be false. And since the boolean value is false, we will not going to take this 3 as a part of our answer. Now we will go to left. So from here we will go to 7. The boolean value gets true, but we can see over here that the left and right child are not null. So we will not going to take as our part of answer. Sorry for the delay. Now we are moving forward in our recursion. After this 7, we will again go to left from here to this 10. Since we are moving to left direction, the boolean value gets true over here. And here we can see that the left and the right part of this root 10 means if of this 10 is null. So this will going to be the part of our solution. Now since it's a recursion, it from this 10 we go to again we will go to 7, and from here we will go to 9. So as we move on to 9, we can see that the left and right part are null. But since we are going to write, the boolean value gets false, and that's why 9 will not be the part of our answer, or we can say 9 will not be the part of this summation. Now again we will go, since it's a recursion, we will go to 7, and from 7 we will go to 3. Recursion will do backtrack always, and from this 3 we will go to this 8. Since we are moving toward right, the boolean value gets false over here, and 8 will not be the part of our summation. And from this 3 we will from this 8 we will go to 3, and from this 3 we will go back to this root node, and at here again we will check that is the left and right part of this tree is null, and the answer returns false. So this one will not be the part of our summation. And finally we will get 4, 6 and 10 as a part of summation, and these values gets add and returns the value, or we can say we store this answer in another variable, and we will return this answer for printing. So this is our approach. Let's come to the coding part, that how we will going to solve this. So let's come to editor. First we are going to do this in Python, and after Python we will also see the solution in C++. So as I said this, that for the solution of this problem we need one boolean value also, which gets get again and again in recursion. Means again and in recursion call, if we have to pass that as false or true. So since the predefined method that we got over here has only one, that is root. We have only one variable, that is root. So which is pointing to this 3. In example, it is pointing to this 3. So we need to take one helping method, and so that I'm taking it as solve. So first, let's take one variable for storing the answer. So I'm taking ans answer equals to 0. Initially it has 0, and now I'm declaring one method def solve. Since it's a method, that's why I'm putting. If I can also declare this method inside this method, and it will become, then it will become a function. Then we will not going to use self over here, and in calling also we will not going to use self, but we are declare for simplicity, I'm declaring it outside this method, so it becomes another method. That's why I'm putting self over here. Root comma chk is for checking, means this is the boolean value that we are going to check. So I will call this method after later on. So let's discuss let's implement the logic that we have discussed up till now. So the base condition is always same, that if root is none, then we will return. If root equals to none, we have to handle this condition over here, so it will return 0, because at none, if we return none, then somewhere it will use it as a summation part, and it will generate error. That's why adding 0 will not affect our solution. So now we will put condition that for checking the leaf node, as we discussed, that leaf node is that node which don't have any left child or any right child. So I will write if root dot left equals to none. As I said, it will be null in Python, same as none in, sorry, null in C++, equals to same none in Python. And root dot right equals to none. As I said that at this point we will also check that our boolean value, that chk carrying the boolean value, is false or true. If it is true, then only we will add that value. Means if we are at 6, so at that point the boolean value is true. So if this leaf condition gets true and also the boolean value is true, then only we will going to add it in our answer. So if and chk equals to true, then we will came in under if, and we will, since this ans is a part of this class, that's why we have to call it using self. So self dot ans plus equals to root dot well. Since we can see over here in this class, which is defining the structure of this tree, here val is given, that's why we are using val over here. So we came out of this if condition. Now we have to follow the recursion. So as we can see that we are going on the left side, so I will call this, I will pass root dot left in recursion. So self dot solve root dot left comma in, if we are going on left direction, then this chk value will get true. And suppose if we are going on, so since we are traversing on the left side, suppose we came over here 9, so this means we again have to go back to this 3, and after 3 we have to traverse on right side. So that's why I'm going on. So self dot solve root dot right. So as we have discussed earlier, if we are going on right direction, means if we are moving to this right, so at this point what we have to send in chk, we have to send false. So I have sent false. Means if we are going on right direction, then because in our solution we have to add only the leaf nodes on of left side. So suppose if we are going on right side, means up to this 7, then we will pass this false. So over here it will get false, and because of this end, it will not going to add in our answer. So we will only get the addition of the leaf nodes of left side. So this is our whole logic that we have discussed earlier. Now we have to call this function. Since ANS is a kind of global variable over here, so we don't have to return any value from this function. As soon as we call this function, the logic gets implemented and ANS stores the answer. So over here we check one condition. If we don't put this condition over here, then also our solution works fine. So I will show this later on. If root equals to none, then we will return 0. So no need to go on recursion for the checking of this condition. That's why I'm checking it over here only. It just increases the sum time complexity. So now we have to call our helping method. So I will call self dot solve root. Since we are on the root node, which is not the part of our answer, that's why I'm passing initially false over here. Now, sorry for this interruption. So we have called this method over here. Now we just have to pass the answer. So sorry, now we just have to return the answer. So return self dot ans. So I'm going to run it now. Okay, the initial test case gets passed over here. Now submit it. So we can see over here it runs completely fine. So our logic is correct 100%. And so you can see over here that we have implemented everything that we have discussed earlier. So as I said, we will going to see this solution in C++ also. So let's see the solution in C++. So we can see over here, it is almost same, or we can say 99.99% same. Just we have implemented like Python, we have implemented the same logic. We have taken the same solve method over here, and if root equals to null, in C++ we take none as null. So return 0 if root of left equals to null and root of right equals to null and chk equals to true, then we will going to add it in answer. We have also declared over here answer as globally, and same we in this we have checked that if root of left not null, since we are on the tree that have left child, so we have just add this condition over here. Then we will going to call the recursion as root of left and comma true, means we are if we are moving toward left, then we are passing true, and if we are passing over right, then we are passing false. So if we are moving toward right, then we are passing false. And since we can see over here that if we use int over here, then we have to return some value from this method, otherwise it will generate an error. In Python it doesn't require to declare anything return type, but in C++ we have to do this. So if we are writing int over here, then we have to pass something. So that's why finally I am returning 0 over here, but it does not going to affect our answer at all, because after passing we are not catching this 0 at anywhere. we can see over here in the calling function or calling method. So we have just checked the initial condition. If root equals to null, then return 0. And in we are just calling that method only for storing the summation in answer. And this 0 that we are returning, we are not catching it anywhere. As we can see, I just called the method as solve root and passing root comma false initially, that we did in Python. So this returning 0 will not affect at all. And after all, I just return the answer from over here. So okay, let's check one more condition. As I said that if we are omitting this, if root equals to none, then also our solution runs fine. So let's check it over here. So we can see over here, if we are omitting this initial condition, then also solution will run fine. And but it somewhat somewhere it increases some complexity. That's why I'm checking this condition. Suppose if the initially the root is null, it has nothing, so we will just return 0 from here only. That's why I've used it over here. But if we are not using over here, then somewhat it increases the complexity, because it will go up to this method, and from here it will check and returns 0. So that's why I use this condition over here. So if you all want to use this condition over here, you can. Otherwise, if you omit this, then also the solution works completely fine. So thank you for watching. That's all for today. We will meet again with the new problem of DSA. So these problems are very important. These are most of these questions asked in interviews like Amazon, Walmart, Google, Facebook. So thank you. We will meet again. That's all for today.